Good morning, everyone. Now, as we have discussed that it is not advisable to set the reach of the distance protection to 100%. The first step of distance protection is therefore to set the reach to 80 to 90% of the length of the line section. So this is the instantaneous protection, and there is no intentional time delay in that. So what we are discussing the three-step distance protection, because we have discussed that it is not advisable to set the reach of the distance protection up to the 100%, that because they can underreach or the overreach. So three-step distance protection is used for that very purpose. Now the first is the first step we can discuss, then the second step, and the third step. Now some of the rules for that is that the first step of the distance protection is to set the reach up to you can say that 80 to 90% of the length of the line. Now let us suppose that we have the line which needs to be protected, that is A, B and B, C. So the first protection is used up to this point, that is 80 to 90% of the length of the line section, and this is instantaneous protection, so there is no intentional time delay in that. So similar is the case that first protection is up to 70 to 80% of the line section. Now the second step is required to provide the primary protection to remaining 20%. So the second step is required to provide the primary protection to remaining 20% or 20 to 10% of the line which is left out in the first step. In addition to it, it is set to cover the 50% of about the 50% of the next line section. Now this is the next line section is BC. So it will cover the 50% of the next line section, as we have seen, that 0.8 to 0.9 ZAB up to that, then ZAB plus 0.5 ZBC. So it will cover this line also, this one also, that is which is left 20 to 10% of the line which is left in the first section, and it is set to cover the 50% of the next line section also. As clear from this diagram, you will see it will cover the adjoining line section. Now what is the motivation behind this? Motivation behind this extended reach is that it should provide the backup to the next line section including the bus. So it should provide the backup to the next line section, backup to next line section including the bus, and in the event of the maximum underreach, it should be able to cover the bus fault at the bus between the two lines. So in the event of maximum underreach, it should be able to cover the bus fault at the bus between the two lines. So the operating time of step 2, step 1 plus selective time interval that we have discussed. And what is the selective time interval? Circuit breaker operating time and relay over travel time. Circuit breaker operating time plus relay over travel time. So when there is more than one adjoining lines, let us suppose that we have the two adjoining lines, that is One is the short line and one is the long line. The second step should extend to the 50% of the second line. So in case we will have the short and the long line, then second step will extend to the 50% of the shortest line. If it is set to reach the 50% of the longest line, in that very case, there is the loss of the selectivity with the second step. As we can see from this diagram, here we will see false. Here we will have what we have. We have the one is the long line, that is B and C, and another is the short line, that is this one B and D. Now let us suppose that there is the fault in the region between D1 and the D2. Let us suppose that there is a fault in the region between the D1 and the D2, as it is clear from here. D1 and the D2, this one and this one. Let us suppose that there is this fault in this, and these are in the second step of the primary protection at the bus B, provided by the relay RB. Now, as well as the second step of the relay RA at the bus A, as well as the second step of the relay RA at the bus A. Therefore, there is the loss of selectivity between the second step of the distance relay RA and RB, and hence the second step of distance relay is set to reach up to 50% of the shortest adjoining line. One more, again we can discuss that. Let us suppose that there is fault in the region between the D1 and D2. Here, as we have seen, that there is the fault in the region between D1 and D2. Now, if you see that if we have set the reach for the longest line, in that very case, what happens? In the D1 and D2 are in the second step of primary at the bus B, provided by the relay RB, as well as the second step of relay RA at the bus B. So it is actually it is the second step of primary protection at the bus B. So it is at the second step of the primary protection at the bus B, RB, which is providing the second step of the primary protection, and provided by the relay RB, and the second step of the second step of the relay RA at the bus A. So there is the loss of selectivity between the second step of the relay RA and the relay RB. So the second step of distance relay is set to reach up to the 50% of the shortest line. So that thing we have to take into consideration. Now, next is the third step. So what is the third step? What happens in the third step? The third step is provided with an intention to give the full backup protection to the adjoining line section as well. So this is the third step. It is provided to provide the full backup to the adjoining line section, and it covers the line section under consideration. That is, it covers the 100%, which is line section which is under consideration, 100% of the next line section, and reaches further into the system. Now, what is the motivation behind the extended reach of this step? The main motivation is to give the backup to the next line section in spite of the maximum under reach of the third step. So this is all about the 3-step protection of the this transmission line, 3-step distance protection. Now, also we will have, there is an additional distance measuring unit. So there is an additional distance measuring unit whose reach is beyond the third zone. And operating time of this unit is instantaneous, and this unit is known as the fault detector or the starter unit. So along with that, this is the fault detector or the starter unit, that is F0. Now the three-step distance protection we have seen here. Now there is an additional distance measuring unit whose reach is actually beyond the reach of the third unit, and the operating time of this unit is instantaneous, and the unit is known as the fault detector or the starter unit. So we will have from this what we get that we will have this. First of all, we will have this protection, that is 8 to 9%. Then we will have 0 to 5%. That, but this rule we have to take into consideration that it is given to the smallest line, not to the longest line. Then the third step is up to 1.2%. It is the 1.2% of this line, that is 20% of this line. Now again the same information is displayed here. Now F0 is actually in this case is the fault detector unit or the starter unit. So the RX diagram for this is given by this, then Z1, then the zone is Z2, then zone is ZT, then F1 is the fault detector of the starter unit. Now everything related to that is tablet here, and then we can explain what is the philosophy of the three-step this distance protection. So we can summarize it. Now what is the first step? Now the first step, it gives the primary protection and 80 to 90% of line section. Instantaneous, no intentional time delay is there. So it avoids the loss of selectivity with protection to the next zone in case of maximum overreach. Second step, primary protection of 20 to 10% of the line which is left in that, and 100% of the line under consideration plus 50% of the shortest adjoining line. That is 100%, it will provide the backup protection. And then we have the T instantaneous with selective time interval that we have discussed. Now it provides the primary protection to the part of the line left out in the first step and provides the backup to the bus and the next line. Shortest adjoining line is to be considered, and if the longest adjoining line is considered, then it causes the loss of selectivity. Now the third step, so it provides the backup protection, 100% of the line under consideration, however 100% of the longest line plus 10 to 20% extra that we have discussed. Then we have T1 plus selective time interval equals to T2. So idea is provide to full backup to the adjoining line even in case of the maximum underreach, and the longest adjoining line has to be considered. If the shortest adjoining line is considered, then longer adjoining line will not get the backup protection. So this is actually the philosophy of the three-stepped distance protection. So this is the main philosophy of three-stepped distance protection. So now we will discuss the trip contact configuration for this three-stepped distance protection. Now here we will have the this trip contact circuit which implements the three-step distance protection scheme. The fault detector initiates the timer in case it detects the fault, and there are different contacts like you will see. This is the no contact, normally open contact of the fault detector. Then Z1 in that very case is the normally open contact of step 1 measuring unit. Then Z2 is actually the normally open contact of the step 2 measuring unit. T1 is the normally open contact closed by the timer after the T1 by the timer after time T1 after the closure of the this fault detector. And Z3 is the normally open contact of the step 3, and T2 is the normally open contact closed by the timer after the time T2 after the closure of the fault detector. Now the fault detector initiates the timer in case it detects the fault within its reach setting. The timer issues the two outputs after it gets energized. The first output is after an elapse of the time t1, and the second after the time t2. Both these outputs are in the form of the closure of the normally open contacts, that is NO. Now, in case of the fault is within the first step of the distance protection, the trip coil get energized through the Z1 and FD contacts. Through Z1 and FD contacts, depending upon whether the fault is within the second or the third step, the trip coil get energized through the series combination of either Z2 T1 or Z3 T2. So this is the trip contact configuration for the 3-step distance protection. Now, the 3-step protection for 3-phase line against all the 10 faults. We have already seen that 3 number of phase fault measuring units which are fed with the delta voltage and delta currents, and the 3 number of ground fault measuring units which are fed with the phase voltage and phase current compensated with the residual current are required for the complete protection of the 3-phase line against all the tension faults. So we already discussed that 6 measuring units are required. The setting of each measuring unit is based on the positive sequence impedance of the line. Now, in order to generate the 3 zones, in this case you will see it needs 3 into 6, 18 measuring units are required. 6 measuring units are required and 3 zones are generated. So 18 measuring units are required. This is rather a costly affair, and the schemes which save upon the number of measuring units has been devised. Now, one popular idea which is known as the switched distance scheme use only 3 measuring units. So switched distance scheme it use only the 3 measuring units but switches the input to them with the help of the fault detector, and this actually brings the number of the measuring units from 18 to 9. So this is the anybody wants to learn about that, he can search the literature for that very purpose, because it is the area of research. Now, what is the impedance seen by the relay? Up till now we have assumed that the CT ratio as well as the PT ratio is 1:1. In practice, the CT ratio as well as the PT ratio is far from the unity, that you already know the fact. In such a situation, what is the impedance seen by the relay? That is the secondary of the CT and the PT, as we have seen here in this diagram. So from this figure you will see, we will see that VR, that is the secondary voltage, is given by VL by PTR, then IR, IL by CTR. Then definitely from this we will PTR equals to PT ratio, as we know that, and CTR equals to CT ratio. So this is obvious. Now, Z relay equals to VR by IR, that we have already calculated. So substituting the value of VR and IR is VL divided by IL into CTR by PTR. So we know that this one is ZF, fault impedance. So finally we are getting CTR divided by PTR. Z relay is ZF into CTR by PTR. So ZF is the fault impedance as seen from the line side. It is the fault impedance as seen from the line side. So this is the impedance seen from the relay side or the line side. Now this is all about that. Now we have discussed the protection for a singly fed system. Now we will discuss the protection for a doubly fed system. Now a figure here shows the double end fed line, that is AB. It is actually the double end fed line, that is A and B. So there are sources at the both the ends, here and here. There is an in feed or the fault power from both the sides, and the circuit breakers and three-step distance scheme will have to be provided at both the ends. Now if we provide the three-step distance scheme, here it actually shows the time versus the reach characteristics of that. So in this case we have here we have the time, and here in this case we have the reach. So it is the time versus reach characteristics of three-step distance protection at both the ends of the line. Now it can be seen that if you see that only 60% of the line 60% of the line gets the high speed distance protection. The remaining 20% here and the 20% here is left, that is it falls in the step 2, and which is delayed one. So this is clearly not a good situation. So we need to prove upon operating time for the rest of the 40% of the line, because what we have done if it is only a fed system, then we have to take 80% of that, 20% is left, and but here we have this fed system, we have to take this one and this is left. So finally the protection, high speed protection, is given to only 60%. Now one scenario is there, then a fault in the end 20% of the line falls within the first zone of the distance relay installed at the nearest end, and there is no ambiguity about its location. The same fault, when seen from the far end, because of uncertainties involved, could well be beyond the bus. If we see this, if it is in this area, then it is beyond the bus. It is well aware of that. And if let us suppose that the power is from that, then this 20%, this fault is in that area, it is beyond the bus. Thus what we do, if we somehow convey the information that the fault is within the protected zone to the far end, then the tripping from the remote end need not wait till the time t1 of the second step. So what is happening, that if we convey the information, what information we have to convey? Fault is within the protective zone to the far end. Fault is within the protective zone to the far end, that if we convey the information from this to this, that the fault is within the protective zone to the far end, then in that very case the tripping from the remote end need not wait till the time t1 of the second step. So this principle actually made use of the carrier aided distance protection. So this principle make use of carrier added protection. This one. So this is about the distance protection. So thank you very much.